This is section 4.3, part 4, where we are going to find the roots of quadratic functions. You can see in red I've written roots are the same as zeros. So sometimes you might see directions telling you, or somebody might tell you to find the roots of a quadratic function, or find the zeros. They're telling you to find the exact same thing. But what does that mean? All right, what does it mean to find the roots? What does it mean to find the zeros? What that means is you want to find the spot where, when graphed, the graph crosses the x-axis, your intercepts, your x-intercepts. All right, essentially. All right, and a parabola, all right, we know a quadratic forms a parabola, is a U-shape. And what you're used to seeing is that it will cross the graph. If it crosses the graph, it crosses the graph probably twice, sometimes once. All right, so let's take a look at what this graph looks like. So I'm going to pull out my graphing calculator, and I'm going to type in this equation. So I've got x squared minus 13x plus 42. And I realize it says equals 0. You can think of that as a y. What I've done is I've substituted the y for 0, so I can find the values of x that make y 0, and thus we'll be at our x-intercepts. All right, so when I graph this function, I'm going to go to zoom 6, and I see my graph here, and it comes down, and the window that we have currently, it looks like it might only touch it in one spot, touch the x-axis in one spot, but it really crosses twice. Alright, so what I'm going to do is I'm going to zoom in. So I'm going to go to this trace button, and it's going to allow me to trace along my parabola, and I'm going to push to the right, and you can see this little spot comes in, and I'm going to move that trace button close to my vertex. Alright, I don't know if it's exact what my vertex is, but I'm going to go close, and then I'm going to zoom, go down to number 2, and I'm going to zoom in and get a closer look. And we can see the vertex is down here, and I've actually crossed the x-axis twice. These are my roots. These are my zeros. So the numbers we get will be these two values, the values of where this parabola crosses the x-axis. How do I find those numbers? Well, what have we been doing the whole time in section 4.3? Factoring. So you want to factor this trinomial right here. So we're going to analyze what we have. We have a positive c. So I know to get a positive number, all right, we're going to multiply two numbers together. So I either have to multiply two positive numbers or two negative numbers together to get a positive outcome. So I'm going to come over here, look at this right here, and this is going to say, well, when added together, I need to get a negative. So I'm going to multiply two negative numbers together to get a positive 42. So I want to find the factors of 42. Both factors are going to be negative. So I'm going to start with 1. 1 goes into 42 times. We know both factors are negative. Negative 1 plus negative 42 gives me negative 43. Negative 43 is not the number I'm looking for. I'm looking for negative 13. So those factors didn't work. Let's try 2. 2 goes into 42 21 times. Both factors are negative. Negative 2 times negative 21 is positive 42. Add these two numbers together, and I get negative 23. Still not negative 13, but I'm getting closer. I went from negative 43 to negative 23. What about 3? 3 can go into 42. Goes into 42 14 times. Both factors are negative. So negative 3 plus negative 14 is negative 17. Still not negative 13, but getting closer. 4. Well, 4 doesn't go into 42 evenly. 5 doesn't either, but 6 does. 6 goes into 42 7 times. Both factors are negative. Negative 6 plus negative 7 is negative 13. That's what we want. So these are the factors we're going to use. So we know we've got x minus 6, x minus 7. Those are equal to 0, so I want to find the value of x that makes this binomial equal to 0, and the value of x that makes this binomial equal to 0. So in order to do that, I simply set each binomial equal to 0. So I have x minus 6 equals 0, and I have x minus 7 equals 0. And then I solve each one-step equation for x. So in this case, I add 6 to both sides, and I see x equals 6. In this scenario, I add 7 to both sides, and I can see x equals 7. And these are my zeros. Right, so if I come back to this graph, and I move this crosshair over, and I try and get to that intercept right there, and I can see when y is 0, x is pretty darn close to 6. Alright, it's not exact. If I zoomed in closer, I'd get to be exactly on 6. Alright, so I know that that's correct. And then I can arrow over in this direction. So I'm hovering over around the second intercept, which is pretty much 7. So you can see the two intercepts of the graph are the two zeros, or the two roots, are x equals 6, x equals 7. Alright, so let's come on down. Last problem of the section is x squared minus 81. Hey, that looks like that might be a special pattern. Alright, you want to ask yourself 3 questions. Do you have a binomial? Yes, you do. Is there subtraction? Yes, there is. Are each of the terms perfect squares? Yes, they are. So if you answer yes to all 3 of those questions, you know you have a special pattern. So I can take the square root of x squared, and I'm going to get x. I can take the square root of 81, and I know I'm going to get 9. So I'm going to have x minus 9 times x plus 9. Set that equal to 0. So I'm going to find the value of x that makes this binomial equal 0, and the value of x that makes this binomial equal to 0. So I'll set them each equal to 0 and solve. Add 9 to both sides. One of my zeros is x equals 9. Subtract 9 to both sides, and the other 0 is x equals negative 9. And if you were to graph it, you would see the parabola would cross the x-axis at both positive 9 and negative 9. So go ahead and check that. Alright, and that's the end of section 4.3.